In this video we'll speak about the difference between a dangling pointer and a memory leak. So we started off by allocating memory dynamically on the heap. So what we've done is we created an object of an integer object of value 30, and let's print out the value in the address. And then what we did is we've assigned that same pointer another object and given it the value of 40 and printed out the address and value of it. So let's compile and run. So we notice that in the first assignment that we've done here, the memory address is different with a value of 30, and the second time we've assigned a new object to that same pointer, it's a different memory location with a value of 40. Now here is the memory leak. It's this object in memory that we can no longer reach. That's the memory leak. Now the fix to the memory leak is to actually delete what the pointer is pointing to before assigning it a new reference. And so that would be before we give the pointer a new value, let's delete this object. This is how we avoid the memory leak, and I've got it here in a comment. Now the integer 30 is now lost in memory. This object can no longer be referenced or used. This is an example of memory leak. So we want to delete this object, and to do that we use the delete keyword and delete what we're not deleting the pointer, we're only deleting the object it's pointing to. Now this is how we can avoid or fix the memory leak. Okay, now I'm just gonna comment this out for now. Sorry, I can't. Okay, so the fix is to delete what the pointer was pointing to before assigning a new reference to it. Okay, so I've got it in here. So that's deleting the pointer. Now in this case, at this point, we can avoid the memory leak by just deleting that object. But what happens now is APTR at this point only. At this point, so with this stage here, now APTR is also a dangling pointer because it still points to a deleted memory address. Now the fix is to either set it to null or assign it a new reference. We are going to assign it a new reference and make it refer to another integer object of value 40. And that's the difference between the memory leak and the dangling pointer. I hope it made sense. Keep in mind that if you delete what the pointer is pointing to, that's going to avoid the memory leak. But do not forget that to avoid the dangling pointer, that it now points to, at this point it will point to a deleted memory address. Now if the program hasn't finished yet, you want to either set that pointer to null or give it a new object like we've done. And it's always good practice to delete what the pointer is pointing to before the end of the program. And I hope this made sense. I'll see you in the future.